I guess for those of you that don't know me, I'm Kurtis McBride. I'm the CEO of Miovision, one of the companies over on the right side of the show here. I guess first I'll just say it's nice to be back in market. It's been 2 years since I've been to a trade show. I've been talking to a number of people. For some at least, it's the first show in a long time. So it's great to actually be back and to see everybody. And thank you all for coming out to listen to me today. I'm going to, I'll start us off with a quote here. This quote is often attributed to Albert Einstein, but there's no proof that he actually said this. But we can give him credit for it. He probably deserves it. So definition of insanity is doing the same thing over and over again and expecting different results. When we started Miovision about 15 years ago, before we started Miovision, I'd done a program in university that was an internship program. So I was a co-op student. So every 4 months I was either in school or working. And my last co-op job, I got to work for a transportation engineering company. And on the weekend, I would get called out to do these traffic counts. So you would sit outside in July in the baking hot sun in Toronto with a little clicker board, and for 8 hours, you'd count how many cars turned left, went through, went right. And I remember thinking, like, this is probably the worst job you could ever have. And someone should really try to change something about this. And so we coming out of university, started Miovision to try to take this world of manual intersection counts on, and built a product called Scout that has become sort of the de facto standard way to do that type of traffic count. So the point is really from the beginning of the company, we founded the company. The cornerstone of the company was this idea that you could look at the future and imagine it being different than the past, and try to make something better about an industry. And that's sort of been the underpinning of everything that we've done since then in the 15 years we've been growing the business. Today I'm going to talk about a few different things. I'm going to take a shot at describing in my opinion at least, the fundamental reasons why traffic continues to be a challenge, like why we have congestion, why we have traffic safety issues. Going to look at the unit economics of our industry, sort of driven by the architectures that have been built up over the last several decades. I'm going to talk a little bit about some ideas about how we might take that challenge on in a different way. I'm going to talk about industry examples outside of our industry where these kinds of transformations have happened in the past, and then I'm going to propose some next steps. So I'll get us all situated here. Fundamentally, our market is broken up into two different pieces. We have vendors and products that operate on each side of this. So the one side is infrastructure. So these are like the physical things that go out at the side of the road, right? The cabinets, the controllers, the MMUs, the communications, and then we have services. We have engineering services like signal retimings. We have design. We have maintenance, and all these kinds of pieces. But the thing that kind of binds us all together across these two different parts of the market is that we're trying to create safer, more efficient flow of traffic, right? So, fundamentally, if you looked at any of our brands, any of the vendor brands in this market, we all kind of hint at that as being our overarching sort of why. And whether we compete or partner together, fundamentally, we're all sort of working towards this fundamental objective. But yet, traffic, if you stood around any water cooler in the office, traffic continues to not be as efficient as it could be. Traffic fatalities continue to plague road users. And I look at it and I think there's sort of two fundamental reasons why. So one is the procurement systems that we have been built up around these two different markets, right? So we have procurement systems that buy stuff, and we have procurement systems that buy services. It's very difficult if you come along with a 21st century product that combines those two things, right? That has both hardware and services in one. It's very, very difficult for the traditional procurement systems to know how to actually buy those things because the market's not built up around that concept. And then the second thing is the architecture of an intersection is is fundamentally anchored in the safety device, the MMU. So it sort of forces everything in that architecture to ultimately be analog. Even if there's digital things in there, the architecture fundamentally has to talk analog in order to comply with the safety device. So we have sort of a system architecture problem that prevents us from truly moving into a 21st century paradigm, and we have a procurement architecture problem that forces us to pretend that we're always going to want to run these two parts of the market as separate things, as opposed to trying to put them together. And so here's where I'm going to assert my hypothesis. I think you can boil this whole problem down to one thing, which I call the refresh rate, the intersection refresh rate. So if you imagine intersections today, and obviously intersections are complex, there's lots of different components, so I'm going to kind of grossly simplify this, but intersection refresh rate today, probably somewhere on the order of like 20 to 25 years, where we buy an intersection, we run it for 20 to 25 years, and we upgrade the components at the intersection on a regular basis. However, innovation rates, consumer innovation rates are probably 2 to 3 years. Industrial technology rates, innovation rates are maybe 4 to 5 years. So we have this incompatibility between the rate at which we refresh infrastructure and the rate of innovation. And this ultimately leads to bad traffic, right? Congestion issues, safety issues, because we can't, even if we invented a way to fix traffic tomorrow, it would take us 25 years to deploy that fix, and then we would be 5 generations behind by the time we got it done, right? And again, gross oversimplification, but fundamentally, this is a function of unit economics. So if you take the budgets we have in our industry, right? Let's say we have $100 worth of budget, and we divide it by the unit cost of an intersection over that 20 to 25 year life. Let's say that was $20. You can install 5 intersections per year, and then 5 into 100, you have a 20-year refresh rate, right? So the only way to change the refresh rate is to change one of the variables in this ratio, right? So go back, sorry for the equations, but if we go back to grade 9 math, you have your numerator and your denominator. You got to pick one you're going to change in order to change the rate. I don't think we're going to see a 5 to 10x increase in budgets to drive an increase in the refresh rate. So really that leaves us with the cost of an intersection as the variable that we actually can play with, right? And so the question becomes, how would you engineer a step function change, like an order of magnitude change in the total cost of an intersection over its useful life? So let's look at that. What is the cost of an intersection made of? Well, it's got 2 components. It's got the capital cost, right? Buying the infrastructure, buying the stuff, the cabinets, the controllers, the MMUs, the communications infrastructure, and it's got the operating cost. So the ongoing cost of having signal retimings going on, ongoing maintenance costs, the software that you might install to run an intersection. And if we kind of look at this, and every intersection is different, every market's different, what you put into the intersection, how big it is, all these things drive cost. But again, if we keep it simple, the average total cost of an intersection over its useful life, over the 20 to 25 years, somewhere on the order of $250,000, right, that we spend to build the intersection, put all the stuff in there, and then manage it on an ongoing basis. So how would we create a 5 to 10 times reduction in the overall total cost of an intersection? So if we look at it, things cost what they cost, right? Like anyone who's ever opened up a traffic cabinet, there's a lot of stuff going on in there, right? So it's not really reasonable or feasible to think that we could create an order of magnitude decrease in the cost of an intersection, because there's a lot of stuff in there. Stuff has to get manufactured, has to get shipped, and then time to manage, to do signal retimings, for example, software to buy, all these things cost money. And in the inflationary environment we find ourselves in, costs are likely to go up more so than they are likely to go down. Certainly not going to go down by an order of magnitude. So I was tempted to end my talk here and just be like, well, there's nothing we can do. But I figured we would go on and explore some ideas about how has this played out in other industries where this same unit economic step function change in cost has occurred. And I believe there's actually a massive opportunity in our industry to reorganize how we spend that $250,000 to not only drive down unit economics and improve the refresh rate and create better outcomes, but actually to increase the size of the market. And I'll talk a little bit about where I think that could come from. I think about half the people in this room work for me, so they're going to laugh because this is all, I talk about Elon Musk pretty much every day. But one of the things I really admire about this guy is that he has a way of looking at problems from first principles. So rather than taking a look at, well, we've always done it this way, therefore we should do it that way, he tends to look at it as like, what's the best way to do it? The two examples that are, all over the news today, Tesla and SpaceX. Tesla, the prevailing wisdom was electric cars are impossible because batteries are too expensive, right? But then he looked at the actual input costs of the batteries and said, well, this is not true. Nickel's cheap, and if you made batteries at scale, right, is a scale problem, not an input material cost problem. If you made batteries at scale, you could actually make electric cars not only that were more affordable than regular cars, but because you could bring a whole bunch of technology to bear, you could probably make them safer, more fun to drive. SpaceX, the prevailing wisdom was we build rockets, we send them up into orbit, and we burn them up, and they land in the ocean, and that's that. And therefore, space travel is really expensive. He said that's crazy. Why don't we just land the rockets on barges in the ocean? Everyone said it's impossible. Now we land barges on rockets on a regular, land rockets on barges on a regular basis. So by looking at the problem from first principles, right, challenging the prevailing wisdom that has been applied for decades, he was able to take two industries that on the surface seemed like they couldn't be changed, couldn't be innovated in, and he's brought innovation to them in a fairly material way. One of the things that happens when you do that is all sorts of new economic opportunities build up around those changes, right? So it's not that by dropping the unit economics in these businesses that he necessarily put everybody out of business. He just shifted the economics around to create a lot more opportunity. And I would argue in the launch market in particular is about to go through a renaissance. So there's going to be an explosion of opportunity because those unit economics dropped so precipitously. In those industries, convention was holding them back, right? In automotive, in the launch services business, convention was holding them back. I argue that convention holds our industry back as well. We've been doing things a certain way for so long that we've forgot to stop and ask ourselves, is there a different way that we could approach this? So I've had the opportunity to sit down with some of the bigger, we'll call it big data, the FANG companies, and talk to them about our industry. And I can tell you that they are thinking about our industry, right? You sit down with some of these big companies and they are using words like NTCIP. So we're sitting in this room talking about this, amongst ourselves, but people from outside of our industry are also seeing this. They're looking at our industry. They're going, it hasn't really changed in a long time. There's a massive market here. There's a huge opportunity to reorganize the cost structures in this and create innovation. And so, I would challenge us to think about, we're a medium-sized industry in a really big world. And I would challenge us to think about that if we don't start to think about how to make this change ourselves, right? If we don't make it happen by us, it's going to happen to us. So let's do a thought experiment, right? It's a fun Wednesday. What if we did apply first principle thinking to our industry, right? Let's just pretend intersections don't exist, right? We don't have an EMA TS1, we don't have Caltrans 2070s. We invented the car yesterday and we need a safe way to get through a city, right? How would we approach this problem? So what would it take to actually engineer a 10x reduction in the overall cost of an intersection? And as a way to maybe think about this problem, I think most of you are of my vintage where you'd remember what a desk looked like in the early 80s. So think about the desk and think about your careers and think about how much the desk has changed over the course of your careers, right? The things that you used to have, fax machines, desk phones, your atlas or your globe, your calendar on the wall, these have all been replaced by software, right? And looking back, if you're sitting at your desk in 1985, this was kind of crazy to think that everything on your desk could be replaced by software. And fundamentally software that is running on common hardware, right? So before we would buy all of these different pieces of hardware, now we buy software that runs on common hardware. That's the fundamental shift that occurred. And on the surface, this should have dramatically shrunk the market, right? Because now you just needed to buy one device instead of lots of devices. But what actually happened was that some of the largest companies by market capitalization in the world were created because of the changes that you're seeing in this slide. right? So who would have thought that the Rolodex would turn into Salesforce or LinkedIn, right? Like who would have thought that the fax machine would turn into DocuSign, or that the calendar, would turn into Google, that the Atlas would turn into Google Maps. Literally tens of trillions of dollars of market capitalization are represented on this desk from 1980. So the point here is like on the surface, it might be scary to think of moving to common hardware, but it doesn't have to be, because there's actually massive economic opportunity that gets created when this stuff happens. So today we have a set of standards that were built up over decades that are based on this notion that standards define the functions that are delivered by hardware that is meant to be interoperable, right? So at a time, this was really logical. You were buying hardware from multiple vendors. Vendors were trying to use proprietary standards to lock each other out. The industry said, no, we're going to create interoperability so that if I buy this component from this vendor and this component from this vendor, these two things will work together, right? But what if, instead of standards that defined interoperability, what if we defined standards that allowed software to deliver value, right? Functions that were delivered by software on top of common hardware. So what if we did to the intersection what happened to the desk, where we started to say, let's just think about the hardware in a way that allows us to buy common hardware that allows us to deploy all the applications we might ever want to deploy, plus ones we haven't even thought of yet, because we're gonna approach this more like a laptop, more like a cell phone. Who had a Walkman at some point in their life? Okay, so I want you to imagine the Rolling Stones come out with a new album. Okay, it's 1992, you have your Walkman, and what was involved in getting the Rolling Stones music into your ears back then? Someone had to buy plastic beads, lots and lots of plastic beads. They had to centrally ship all the plastic beads to a place where they could melt them down. They had to then press them into the shape of a cassette. They bought a bunch of magnetic tape. They printed the music onto the magnetic tape and they reeled it into the recently pressed cassette. They then printed a whole bunch of album covers that they could insert into hard plastic, which they also had to buy clear plastic beads to make. They put the cassette into the insert. They wrapped it in plastic. They did that hundreds of times. They put them in cardboard boxes. They did that hundreds of times. They put them in trucks. They then shipped those trucks all over North America to your favorite music store. For me, it was HMV. The HMV employee would take them out of the box, would put them on the shelf. I would then get in my family station wagon and drive to HMV on a Saturday. I would give them my hard-earned money. I would take my newly purchased album home. I would slip it inside my Walkman and I would put it on and I would go for a walk and I would listen to the Rolling Stones. Or Bon Jovi, as it might have been in my case. Today, that same album, someone would hit publish and it would end up in all of our hands instantly, right? So here's an example of an industry that moved from a hardware paradigm where we had to buy different pieces of hardware, combine them all together to hear music, to a software-based paradigm where we can now deliver software on top of common hardware. The distribution economics of the content went to zero, right? And it didn't, Sony made music back then. They still make music today. I think Sony's music business is way bigger today than it was back then, right? So it didn't necessarily put Sony out of business in making music. It just changed the unit economics and allowed them to compete in new ways. It opened up that medium and zero cost of distribution opened up opportunities for all sorts of new types of artists to produce music. So the actual industry itself grew as a result. And you can see this play out in lots of different markets, right? We all went to Blockbuster, to rent movies. We forgot to take them back. We paid late fees. Netflix came along, changed the paradigm, changed the underlying economics of that industry. But now, massive content creation, right? Like shows like Squid Game would have had no chance of surviving in an environment where you had to rent or watch it on cable television, right? But now it's the most watched show on Netflix. New content is being created all the time. There's industries, local industries all over North America that are allowing content to be created in tier 2 and tier 3 cities. Fundamentally changed the economics of this industry. And then the other one, also an Elon Musk business, I remember I was an early adopter of eBay. And when you used to sell stuff on eBay in the very early days, people would ship you envelopes of cash, right? So you can imagine that this was not always the greatest system, right? Cash is in the mail, wasn't. You shipped the product, you never got your cash, or someone shipped you cash and you never shipped the product. PayPal came along and said, no, this is crazy. We need a digital system for this. They can build in escrow, can shorten the time it takes to move money around. And eBay ultimately built up on top of PayPal, as did many other businesses. So we can look at, over the last 20 years, we can look at lots of times in other industries where this transformation from hardware-dominated to software-dominated has occurred. And in all cases, it doesn't actually shrink the markets. It massively grows the markets, and it increases the amount of margin that you can generate out of these industries. So if we come back to our market, if we move from a paradigm of hardware, of interoperable hardware as the standard to common hardware, a few things happen. So one is, if you think about the example before of like someone solves traffic, right? There's a new hardware product that solves congestion. I want to deploy that into 400,000 intersections in North America. It's an expensive proposition, right? I have to manufacture it all. I have to go through distribution. I have to ship it out to these intersections. I have to drive to the intersections. I have to install the intersections. If you imagine a world where all the hardware that you ever would need is already there, and that new capability can be pushed by software, it's the same as the Rolling Stones. You can just hit send, and you can distribute to all 400,000 intersections overnight. User experience customization, right? So go back to my music example. In hardware-based paradigms, customization of a user experience is difficult. Imagine if you wanted to go for a 2-hour walk and you wanted to listen to different genres of music from different artists in the time when you had your Walkman. You had to bring a backpack with you filled with cassettes, and then every song you had to switch it out, fast forward, find the song. Not a very easy to customize user experience. Whereas today, we can all go for a walk with our Spotify, and we can switch genres, switch artists, no problem, in whatever customized way, in a way easier, way less input cost kind of a way. But most importantly is this notion of the size of the market. I think if you move from an interoperable to a common standard for an intersection, I think there's a massive market expansion opportunity. I think there's audiences, stakeholders who would be interested in the services you could provide from an intersection, or interested in the data that would come from an intersection, that far eclipse the markets that we operate in today. In so much as you could create a massive market expansion opportunity for all the industry vendors that are here today, if we could all get our heads around this and engineering this kind of transformation. And I think you get this triple bottom line out of it. As vendors, we get to benefit because the market grows, the amount of margin you can generate, it goes up as the distribution costs go down. Customers benefit because their unit economics drop. They can actually do more with their same budgets, right? And then ultimately, the citizens that we all serve get to benefit, right? Safer, more efficient streets, less GHG emissions as we all use data to improve the flow of traffic in cities. So I think you can get this triple bottom line win out of this paradigm change. So before you guys all think that this slide just kind of found its way in here, it's intentional. So from the year 958 to 966, can't read. This guy reigned. He was a Norse king, and he was famous for uniting Denmark and Norway. But he was also famous for having a very visible dead tooth. And in certain light, this dead tooth would appear blue. And so his nickname was King Harold Bluetooth. 1,000 years later, a bunch of companies got together. One of them was from Norway, and they decided to create the Bluetooth standard. And this was the idea that, we're all better off if we stop all having these proprietary wireless communication mediums between our devices. If we all got together and came up with a standard way to communicate between our devices, we're actually all better off because we can ring fence around this Bluetooth protocol. Today, about 5 billion Bluetooth devices exist out in the world, and the market capitalizations of companies that use Bluetooth is in the tens of trillions of dollars. Right? So here's an example of where some seemingly competitive companies got together and said, let's actually create an industry that we can all benefit from because it'll keep everyone out that doesn't want to adopt this, and it'll create massive market opportunity for us. So, to the degree that I'm in a position on this small stage talking to 20 people to, call to arms for the industry, I think that we would be all well served to sit down and talk about the creation of a new standards body that focuses on enabling software-based value delivery on top of common hardware, right? Which is a paradigm shift for the industry. I think that if we can land that, I think it creates benefits for all three of the stakeholders that are listed here, right? In line with the triple bottom line. Creates outcomes for citizens that are positive, safer, cleaner streets, reduction of GHGs. 40% of all the GHGs emitted in a city come from transportation. Creates benefits for customers. There's only so much budget to go around, but here's an opportunity to create fairly transformative unit economics to allow customers to keep up with that refresh rate and create the impacts they need to create in their limited budgets. And it frankly creates a benefit for vendors because there's a bigger market, there's more margins to go around because we've reduced the cost of distribution of this stuff to effectively to zero. It's not lost on me that I'm standing up here as a vendor. There's other vendors in this room. It's not lost on me that what I'm suggesting here is a threat to our business models. And frankly, it's a threat to Miovision's business model too, right? We benefit today from the fact that the world is this way. But I truly believe that someone once told me that all of us are smarter than some of us. And I truly believe that the best way to build a business is through partnership. And I think ultimately the economic opportunity to increase the size of the pie is so great that any competitive challenges this might create for any of us can be more than overcome by the fact that the market would be that much bigger for all of us. And yeah, I love this quote too, but I just think that, if you want to go far, go together. And I think we would be all well served to do this before someone from outside comes and does it to us. So there's my cell phone number. If anyone in this room wants to talk about this, you can call me or you can just talk to me as I step up the stage. Yeah, and I'm happy to take any questions, or if anything I just said is blasphemy, I'm happy to hear about that too.
Hi. I enjoyed the presentation. So in this call to action, is there a proposed first step for the industry?
We have to find a king who's got an interesting name. That's no, I think it's a great question. I think the Free the Mibs movement, I think, has shown us that there's a willingness to it's taken 5 years, let's say, but there's real momentum building up behind that movement. So whether we leverage an existing movement like that and try to expand its scope to include standards development, or whether we find a standards body that is interested in partnering with us to start to think about this or start something new. I'm here to sort of throw the question out, be a bit provocative and throw the question out, and I'm hoping that this starts a conversation. But I think there's different models we could follow to move it forward, but I don't have a specific proposal. I saw Jeff joined Free the Mibs recently, so maybe we can start there.
Using Miovision as a software company or a hardware company, 10 years from now, if this happens, common hardware or software or both?
I mean, I think if you looked at our, yeah, we can hear you. So the question was, is Miovision a software company or a hardware company in 10 years? I think the market sees us as a hardware company, but if you were to look at the percentage of our engineers that are software versus hardware, we're already we're already 90% software. Like we already sort of think about ourselves as a software company, but we ship physical stuff to customers. But I would love, in the same way that I don't know, a good example, like take Android, for example. In the same way that they have a reference architecture and they partner with lots of companies who make the hardware, I think that's where we would love to get to. Is there's lots of companies here that people have been buying intersection hardware from for forever, right? And to me, it makes sense that those companies would continue to be the ones to provide. They have trusted brands, customer knows them, distribution channels exist. So yeah, I think of us as a software company. Any hardware we've ever made is because the hardware we wanted to existed, and we couldn't sell software. So.
Yeah, no, not a problem. So the question I have is, you talked about how, partnering up with the industry and trying to, garner support to develop common standards. I guess the issue, having worked in the industry for quite some time, it's not just the industry, it's really your customers. Mm-hmm. And what you're asking to do is, you've got large cities, those are the easy ones. You get huge cities that have a lot of intersections, you probably can get them on board. It's the municipalities that have, how many signals? 330,000 signals. How many are in big cities and how many are in smaller cities?
Yep.
And I guess it's how do you sell it to everybody else? So, I mean, I don't know if there was consideration taken into, like, maybe not just the industry, but also the customer base that would demand it.
Yep.
Because they may not even be aware of it.
Yeah. Yeah. I again, all these ideas and all these answers will be one man's opinion, right? So, but I look at the LED market as the case study for how this happens, right? So people are not, as much as we all care about the environment, and we're compelled by economics, right? We're compelled by unit economics. So it was when LEDs were saving electricity, they didn't get adopted. They did, but not at scale. It was only when the math of the capital cost and the operating cost savings, when that intersection happened, right? When the capital cost dropped enough where it could more than be paid back by the operational savings, and even financing could step in and do mass proliferation. That's when you saw the adoption go like crazy. So to my mind, that's why I get so focused on unit economics. Until you figure out how to make it economically impossible to not change, right? Because it's just a no-brainer at that point, and you have budget pressures. The mayor doesn't want to raise taxes and not get reelected. To me, that's the trick. If all you do is come out with a technologically more interesting way to run an intersection, it won't get adopted. It has to be an economically more interesting way. And that's why I sort of say it's got to be geared at that sort of 5 to 10x reduction, because I think at that point it's going to be hard to not get the APLs on side and get some of the smaller municipalities on side. But even then, it'll still be the streetlight evolution was still a decade-long transformation, but it really accelerated when those unit economics started to go. So, but I could be wrong. It's the best I've come up with so far. Going once? All right. Well, thank you very much.